Now, let me give a small introduction on what PCA will actually do. Hope you all know PCA is going to be a dimensionality reduction algorithm. Say, for example, if I have a beautiful image and if I need to reduce its dimension or extract the essential features out from those image, then what I have to do, I have to reduce its dimension, or in other words, I need to compress that image. So PCA is one of the best compressing algorithm, and I can also get back the uncompressed data also to the level in which it is being compressed. Based on that, I can get the uncompressed decompression data. Say for example, if I have an image data taken for facial recognition, if I directly use those image for comparison with hundreds of images and it going for testing, then surely it will not be possible if I take all the features at once. Because you know that image is actually a set of matrix features where if I take all the things, it will be a highly complex task. So surely I need to go for some reducible task in such a way that I need to take only the essential features out from the image. I need to go do the comparison. So for taking that essential features, we can use this PCA and we can do the task. Here, what I have done is I have just imported the PCA package from SQL and decomposition, and I have given this particular image from IIM dataset. This is an image from IIM dataset. I have posted these images. In IIM, there are totally some 500 to 600 handwritten images that can be taken for authorship inference or character recognition or sentiment analysis or those kind of projects and researches. So here I have taken only two things as an input as a sample program to show to you. So I have just read by using the CV2. Hope you all know that CV2, the OpenCV criteria. So I have included the OpenCV package and I have read the particular image say A01-00U-03. And for those who are new and you are actually working on IIM, I'll be saying this. This 03 is actually the serial number of the author, and this 000U is a set of similar people, and A01 is the person who wrote that. If you take this entire, there are many people in the same group who wrote that. If you take the entire thing like this, A01 hyphen 00U hyphen 03, this will signify the name of the author who have written this particular document. So this is the thing. So you have to find that A0100U hyphen 03 should not be similar to A02 person. It should be similar to the 04th person here, A01 hyphen 00U hyphen 04. With that image, it should be similar, but it should not be similar to the other person. That is what the case. Next, I read the 04 image also, and then I do the compression task. So what kind of compression I do? Just I extract the blue, green, and red. We know that it is actually already in a grayscale with black and white things. And extracting blue, green, red for those things will give me a larger values for lighter colors. So that I take and I set the number of decompositions to 50. You can start from say 10 to you can go up to the number of samples you have in that particular image. Here I have set it to be 50. If needed, I will be setting 20 also. The thing is, based on what you set actually here, the image will be compressed. That is, the more number of features will be decomposed. Right? If you are actually fixing the higher value, then the image will be represented as such. I will not remove any images. Right? Now, let us see how it is being done. I adjust the PCA parameter to 20 principal components, and I said red transform to be transformed as PCA.fit. Red should be transformed like this, blue should be transformed like this, and green should be transformed like this. So each pixel I'm transforming based on the number of components specified here in the PCA. That's what is given here. Next, I compress it by using the Numpy method. Why? Because we know Numpy is used to perform all complex mathematical operations involving matrices. So I take that and I stack everything. This red inverted, everything I'm actually putting inside a stack, and then I'm using it. I think you can actually I did a mistake that it are not red inverted. This is green inverted. When I was typing, I was type the things the same thing again and again. Then I can actually show what is a compressed image. Now, if you see the compressed image, the much of the features actually is going down. Much of the features are going down. Now you can play with this red inverter, green inverter, and all. What are the things you need to invert? That alone, if you want to see, then you can actually get some better images out from that. If I say that it need not be green, it need to be red alone. I need to act only on red inverted data. It is also accepted. The image will be compressed and the green inverted data will not be transferred. Green will be set as it is. And if you don't want blue also to be taken into account, then I can set this also to be red so that I will not touch green and blue. Only red I will be touching for compression. So those things I can do and I can get some better results. And this is with respect to compression. And now we need to compare two images to understand whether they belong to the same category of people written or different category of people. So what I have taken here is I have taken two images, say 03 and 04, written by the same person. And I have taken a test image also here. The test image over here says that it is going to take a test image as some 03. And the data 1 is 04 and the data 2 is again 03. So though written by the same author, this data 2 should be matched alignedly with this particular image because 3 and 3 are same. So these two need to be matched instead of 4 and 3 to be matched. That is what we are actually going to do. So I have converted into the gray image here and I have performed the histogram for this. Perp histogram construction is actually a complex task in image processing. I'm just using it just because since it's a simple exercise, I'm actually doing it. But histogram construction is not usually appreciated in image processing for when large images are involved. Right? Then I'm calculating doing the same process for test image, data one image, and data two image. And I fix what are the how many number of features are going to be matched. I'm going to fix the matching with respect to data one and test, and matching with respect to data two and test. Everything I'm going to check. And I was going to find the Euclidean distance for the histograms being constructed. So in now this particular histogram is actually called as the feature descriptor. You have extracted the feature, but how you are describing the features of the features of the image are represented by using the histogram. So I find the Euclidean distance based on the histogram values. So square root of histogram 1 minus histogram 2, that's what I will do. This is actually the square root, so I take the square root and add it to 0. Similarly I do this and finally I'll be taking it the whole I actually square it and then I take the square root. Once I add everything, I need to square. That is x2 minus x1 the whole square plus y2 minus y1 the whole square. Like that, you add everything. Finally, you have to take the whole square root. So that is what is given here. Here square is happening and here is square root is happening for the entire. After adding everything, finally I was actually taking the whole square root. Similarly, I have to do it for data 2 also. For data 2 also, I'll be getting how many actually are matching. So C1 and C2 I'll be getting. Now I'll be comparing how much distance is there from data 1 to the particular test image and data 2 to the particular test image. I'll say, and based on I put a small if condition and say, and then based on that I got it printed that data 2.jpg is more similar to test as compared to data 1. Why? Because both data 2 and the test are actually exactly the same, so it is actually being more easily compared, right? So this is actually a very basic exercise on PCA, and you can also do a wide variety of tasks like taking it from a data set and putting it inside various folders and then running it and get some valid results with accuracy settings and all. But just for actually giving some sense on how PCA will work with respect to image data, right?